Alright, I may have gone a little bit overboard with the drawings today, so I hope you like them. I'm going to be talking about APUs. APU stands for Auxiliary Power Unit, and many jet airplanes have them. Jet fuel and air go in, and electricity and compressed air come out. They're usually located in the aft section of the fuselage, and exhaust goes out the tail. They're small enough that they can be started with an electric motor, and the compressed air they provide can start the main engines and run the air conditioning while the engines are off, and the generator on the APU can provide electricity before the engines have started, or act as a backup if the engine-driven generators fail. The drawing I've made here is based on the CRJ-200's APU. Air enters through a small door near the vertical stabilizer and is mixed with fuel inside the APU and burned to spin a small turbine. That turbine is connected to this accessory gearbox, which drives the APU generator to provide electricity. It drives the APU's oil pump, and it's also connected to the APU's starter motor. A small cooling fan is also attached to the gearbox, which draws air in from an inlet on the left side of the fuselage and passes it over an oil cooler. Exhaust flows through a muffler and out the right side of the fuselage. This line provides bleed air from the APU's compressor for engine start or for running the air conditioning packs. There's an APU battery to provide current for the starter motor, and an ECU or electronic control unit, which meters the flow of air and fuel into the APU, along with the FCU, the fuel control unit. The whole assembly is enclosed in a fireproof enclosure, and there's a fire bottle that can be discharged to put out an APU fire. Here's a closer look inside the APU. A centrifugal compressor draws air in through the intake, then passes it to a combustion chamber where jet fuel is burned, and the exhaust spins this centrifugal turbine before exiting out to the right. The turbine spins this drive shaft, which powers the accessory gearbox. Fuel flow to the combustion chambers is metered by the fuel control unit here, and airflow into the compressor is metered by the ECU using something called a variable geometry diffuser. When higher loads are placed on the APU, the VGD can be commanded full open to let in the most air. When the load decreases, it can be moved towards the closed position, letting less air into the compressor. In the cockpit, the indications displayed from the APU to the pilot are its RPM as a percentage of maximum and its exhaust gas temperature.